Hello, my name is Kyle Church, and I am an instructor at Ball State University who teaches computer information technology related courses, including classes that focused around utilizing Linux and both just a simple understanding of Linux as well as a Linux infrastructure course. I also teach courses related to networking as well as security. And I'm creating this video to one, help my students in my basic and advanced Linux courses, but also to provide any additional YouTube users who want to learn more about Linux, some background information about Linux, including how to navigate the Linux terminal. So for today's video, I'm actually going to discuss the Linux terminal. First, we want to understand that Linux itself is not actually a terminal. It is a kernel. If you look at a particular computer system, you have the hardware itself, such as your central processing unit, hard drives, the various fans that keep the system cool, your power supply, again, those are all the hardware. Ultimately, the operating system allows us to utilize the system hardware, but the actual component of the operating system that communicates between the higher aspects of the operating system, such as the software and applications, what actually allows us to the software and applications to communicate with the underlying physical hardware is the central part of the operating system, which is the kernel. And for the Linux distributions, the Linux kernel is the actual kernel utilized by those distributions. Linux itself is not an operating system. Linux is typically considered an operating system when it's paired with GNU. GNU was an open source project developed by Richard Stallman in the 1980s, with his goal in mind being to create a Unix-like operating system for desktop computers. Ultimately, they created that public license. They even created some applications effectively that could be utilized, but they weren't able to successfully create their own kernel. So the Linux kernel ultimately was developed by an individual named Linus Torvalds in the early 1990s, and he ultimately licensed this kernel under the GNU public license. So ultimately, GNU plus Linux is actually what is and ultimately makes up a Linux operating system, which operating systems are typically referred to as Linux distributions. And there are thousands of distributions out there. Most of them are based upon two parent distributions. There are the parent distributions out there, but the most common being Debian and also Red Hat, which is typically referred to as an enterprise version of Linux. With that background information out of the way, I'm going to just dive more into utilizing a command line interface as well as interacting with the Linux terminal, which again allows us to interact with the system kernel, which will ultimately allow the various aspects of the operating system to communicate with the physical underlying hardware. Okay, so first we're going to discuss command line interfaces. And command line interfaces are simply text-based user interfaces that are used to view and manage computer files, computer-based commands, ultimately a way for users to interact with the system through the use of text-based commands. Again, there are different ways to interact with the system than solely utilizing command line. The other way would ultimately be utilizing what's referred to as a GUI, which is a graphical user interface, similar to what you would see on Windows 10, where you see all the various displays with the windows and button clicks and things you can ultimately utilize to navigate the system. With utilizing command line, ultimately we're doing everything through text-based commands. Now, some examples of command line interfaces that you've likely interacted with include the command.exe, which is the default command line interpreter for the Windows NT family. That would include your Windows Server operating systems like Windows Server 2012 or 2016, as well as your Windows desktop operating systems like Windows 10 or Windows 11. You also have the Windows PowerShell, which is another command processor based on the .NET framework for Windows systems. If you are familiar with what mainframes are, most mainframes are computer systems built in the 1970s, 80s, utilized by many different types of businesses. Some of your banks still utilize them, as well as a lot of your grocery distributors. And ultimately, one of such system would be IBM's AS400. It utilizes a control language, and ultimately users interact with that particular system through the use of text-based commands as well. And of course, we also have Bash, which is the Linux command line or shell, And we're going to discuss bash in greater detail after I introduce the concept of a shell. So ultimately, what is a shell? Well, keep in mind when a computer boots on the kernel, or ultimately, in this case, we're talking about Linux, but again, there are other kernels out there. For example, BSD, which is the Berkeley software distribution of Unix, is also a kernel. And you want to understand that Unix is actually ultimately what Linux is derived from. And I'll explain that in the next slide. But ultimately, the computer boots, the kernel recognizes all the physical hardware and enables each component to talk with one another and ultimately be controlled by some basic software. And this includes the most basic set of instructions, for example, that keep the system powered on and ultimately keep it in a safe state. Now, computer scientists ultimately understood that computers without some way to interact with them ultimately are relatively useless. So they developed shells as a way for users to interact with the kernel, which in turn allows users to interact with the physical hardware. And the shell operates outside of or around, which is where you ultimately get the term shell, ultimately operates around the kernel and allows users to interact with the system. There are many different shells out there, but ultimately the one we're going to focus on for this course is bash. Bash stands for the Bourne Again shell. This references Stephen Bourne, who is the author of the Unix shell, SH, or referred to as the Bourne shell. The Bourne shell was the shell on Linux ancestor Unix. Keep in mind, again, Linux is derived from Unix. Ultimately, Torvalds got his inspirations from utilizing different distributions of Unix, as well as a Unix derivative referred to as Minix. Minix was actually developed by a computer scientist by the name of Andrew Tannenbaum as a way for students to interact with Unix. And ultimately, Torvalds got his inspiration from utilizing that Minix OS, as well as utilizing different versions of Unix. And ultimately, we understand that Unix, well, the Bourne shell itself is a command programming language for Unix-like systems defined by the POSIX standards. So first of all, keep in mind, Unix was developed by Bell Labs in the 1970s. It is considered the first portable operating system, which is defined by the POSIX standards. The POSIX standards are defined by the IEEE for vendors to make operating systems compatible with hardware, regardless of the underlying architecture. So ultimately, Unix is the first portable operating system, meaning ultimately it can be installed on many different pieces of hardware, regardless of what the hardware's underlying architecture is. Now, bash is the most common command shell on Linux distros, and it's typically stored in this /bin/bash directory, /bin referring to the binary files. Basically, this is a directory that stores most of your binary-based commands, as well as ultimately bash itself, because bash ultimately is a command. So when you're working with bash, ultimately when you start up the terminal running the bash shell, you're greeted with a prompt. This prompt is usually ultimately is a symbol. Usually it's a $sign symbol, and it indicates that the shell is waiting for your particular input. Now, again, keep in mind that Linux and bash are not the same thing. Linux is a kernel. Bash is simply the application that allows us to interact with the kernel. Its primary job is to run other applications that are installed on the system. So now I'm going to shift focus from focusing solely on bash to ultimately utilizing Linux commands. Bash allows us to have a shell to interact with the kernel, but without any commands, it's effectively useless. So we want to understand what commands are, and ultimately throughout these courses of videos, I'll be going through the different types of Linux commands you can utilize, as well as concepts that are tied to Linux, as well ultimately as concepts that could be tied to any operating system and or infrastructure services. With that said, on Linux and Unix, most commands are stored, I apologize for the typo, in a system directory like /user/bin or ultimately /bin. When you issue a command to bash, it searches specific directories to see whether the command exists. Keep in mind, everything in the Linux world is, or Unix world for that matter, is typically referred to as being located in certain directories. Directories are similar to like files in Windows. Directories basically store other directories or folders. They also store files that include files for commands, like your binary files. So ultimately, when you issue a command to bash, it's going to search for a specific directory to see whether that command exists. And of course, if the command does exist, the command will ultimately be executed. So in terms of working with Linux commands, we want to understand that commands can really be any number of things on a Linux system. We have our actual commands. These are the compiled binaries installed via a package or compiled and installed manually on the system. A package is referring typically to a package that is downloaded by the use of some type of package manager, which package manager is ultimately how we install and update certain and remove certain packages on a Linux-based system. I'll discuss more about package managers in a later video, but ultimately these are all the installed commands on a Linux system, these actual compiled binaries, which could be installed through the use of some package, or you could install them manually and compile them yourself. We also have shell scripts. These are text files that contain a set of commands, and they are set to be executable via certain permissions. Shell scripts ultimately allow you to run other Linux-based commands within them. Very useful for operating different processes. And we'll discuss shell scripts in greater detail in later videos as well. We also have built-in commands similar to actual commands, but built-in commands are actually commands that reside in memory because they are part of the code of the bash shell. We also have aliases. These are typed commands that point to other commands. It's a little less confusing than what it sounds, and it's ultimately something I'll discuss in greater detail in a later video. We also have different functions. These are a bit more complex than aliases. Ultimately, they can do repetitive or recursive tasks, similar to functions you would write in most other computer programming languages, but ultimately a bit more complex concept in the Linux world than simply just a Linux-based command, something we'll again discuss in greater detail in a later video. So we have our basic Linux commands. All commands have a basic structure. Keep in mind, there are a number of different options and arguments, and ultimately those different numbers and arguments will allow you to utilize certain commands for different uses. Keep in mind, everything is case sensitive. We want to make sure we are staying true to the case for those letters that are being typed into the terminal. Although most stuff in the terminal will ultimately be in lowercase. But there will be a few command options or arguments that you'll want to do uppercase instead. We'll explain those as we get to those commands. But ultimately, the basic command syntax includes the command itself, the various options, and then the argument. In this case, we have a command apt-get. Apt-get is ultimately used to install it could be used to install, update. It could be used to remove certain packages. Ultimately, it's a part of a package manager referred to as apt that allows us to either install or update or ultimately remove certain packages on the Linux system. The -f option is actually an option as well as install is an option. -f is typically going to be utilized to fix any issues with installations of a certain package. In this case, the package is Firefox. In this case, the command looks at it as an argument. Arguments are typically going to be packages or files. They're going to be utilized by a command as some type of input. In this case, we're installing a package referred to as Firefox, which of course is simply just a web browser. So ultimately, on the previous slide, I mentioned options and arguments, but ultimately, what are they? Well, options are typically also referred to as a flag or a switch. It's basically a single letter, some cases a full word, most cases though a single letter that modifies the behavior of a command in some predetermined way. It's used to control the output of a Linux command, and for almost all Linux commands, options are typically prefixed, which means they're typically started with a dash. So typically it's like a -f or a -i. And that ultimately that letter is going to correspond to some type of predetermined behavior. We also have arguments. Arguments are typically file names, package names, or really any other data that is provided to a command in order for the command to use it as an input. So I have some examples of a few different Linux-based commands. We have first ifconfig eth0 or eth0. Ultimately, we have the command, which is ifconfig. Ifconfig is a legacy command now on most Linux systems that allows you to gain access to IP information, such as information tied to a specific interface. In this case, the interface being ETH0. It can again provide you with IP address information, including your subnet NASC, as well as MAC address information as well. If you want any more information on IP addressing or MAC addresses, I ultimately will refer you to my videos on networking. We also have wget. or -C, and then we of course have HTTP, and then ultimately a website. Basically, the wget command, that's actually the command that's being used here. It's going to ultimately be used to retrieve contents from a web server. We have the option, which is -C. In this case, that -C will stand for continue. Basically, it continues a partial download that was started by wget previously before actually doing the next install. And the argument in this case is the actual website name itself. And finally, we have the tar command with the CF option. And then ultimately, we have two separate arguments. We have backup.tar, and then we have /home/user files. In this case, the tar command can be used to archive, which basically means it creates archive files, or it can be used to extract archive files. Archive files are very similar to zip files in the Windows world. But ultimately, the different options really depend on what you're going to do with tar. Tar works in different modes. For example, it has a create mode. The create mode typically is going to be signified by a -C option, which is what's being done here. And then, of course, in this case, the -F is the option that points to a file that the user is going to name. In this case, they're going to create a file. They're going to use the create mode of tar. There's also an extract mode as well. But for now, we're going to focus on the create mode. So in this case, there's a create. They're going to utilize tar for create mode, and they're going to point it to a file named backup.tar. And what they're going to do is they're going to back up, this case, a directory, a homemade directory on this system, which is /home/user files. So again, you can see here we have, in each case, we have the command. We typically with the command are going to have an argument. There are commands that are going to be read by themselves. For example, I'll discuss a command here soon called ls, which stands for list. And it's a command when run by itself will list contents of a directory, including all the files and subdirectories within that directory. ls by itself would simply be a command. In most cases, the commands are going to have an argument. For example, we have in each of these commands an argument, typically an interface, a device, a file name, a website, URL. And then we also, on most of these cases, have options. Again, not every command will have options, but some of them will. Ultimately, the best way for you to learn the various options is really just getting more comfortable with the Linux terminal. Also through the use of something referred to as the man or manual pages, which is a concept I'll discuss in greater detail in a later video. But what the man pages can ultimately be used for is to learn all kinds of the different command options available for various commands on a Linux system. As I mentioned previously, bash itself is a command. It's usually the default command executed when opening a terminal window, because ultimately the terminal window is going to be using a shell. In this case, or in most cases, it'll be bash. Now, the which command can be actually used to find out where bash is stored. Ultimately, which can actually be used to determine where any command is located on a system. But in this case, it's being used here to determine where bash is located, which is, again, in the user/bin /bash directory. Now, there are a few commands that are built into bash. ls would be, I would say, one of them, as well as cd, which is change directory. We're going to discuss those commands in greater detail in future videos, but ultimately, you do want to understand that the bash does have some built-in commands. All right, so we also want to discuss running bash. So most modern Linux and Unix distributions provide a bash shell by default. Bash is well known and has several functions that other shells don't. However, keep in mind, bash is not the only shell that's used. Some other systems will use other shells by default. For example, if you're utilizing Mac OS, or in this case, Mac OS X, ultimately it's going to be utilizing the Z shell as opposed to the bash shell by default. But you can install the bash shell if it is not the default shell. Now the command echo with a $sign and a 0, which is referring to a variable. This command can be used to determine what default shell is running on a Linux system. Basically, the echo command prints the output of the special variable. Again, the variable is a 0 being called by the $sign. And it's going to represent the name of the currently running process on the machine, which ultimately, when you open up the shell, is going to be the shell itself. So in this case, it would be bash, or would be whatever other shell is being used on a Linux system. So actually, I'm going to pull up a Linux terminal and start to show you what I mean by ultimately running bash, and by showing you what the default shell is. So I'm going to exit this PowerPoint for a second. I'm going to pull up a Linux terminal, I am utilizing a Linux distro referred to as Ubuntu for this, running on VMware Workstation. VMware Workstation is ultimately a version of VMware that you'd have to pay a license fee for. Ultimately, what it does is it allows you to run multiple different virtual machines simultaneously on the same system. There also is a version of VMware referred to as VMware Player. Player is ultimately one that you can run only one VM at a time, but it's free as opposed to having to pay for a license fee. There's also VMware Fusion for Mac users. Well, of course, you could also use VirtualBox. VirtualBox is another type of virtualization software, typically referred to as a type 2 hypervisor because it sits on top of an existing operating system. And ultimately, VirtualBox is another one you can use that is actually free on both Mac or if you're using a Linux distro to run a VM or on Windows itself. In this case, I'm of course using VMware, and I have Ubuntu 20.04, which is the current most stable version of Ubuntu. Ubuntu is a Debian-based distro. There are other versions out there of Ubuntu besides this 20.04, but 20.04 is considered the most stable version that's currently available. So I'm going to log into the system. And if you want to watch a video that describes ultimately how to install VMware as well as VirtualBox, and also that describes how to actually create a virtual machine, I do have other videos on virtualization that can be useful for you to watch if you have never installed created a virtual machine or installed Linux on a virtual machine. But in this case, on this video, I'm assuming that you already have a Linux terminal that you can access. And ultimately what I'm going to do is I'm going to first issue that command echo with a variable $0. What I'm going to do is I'm going to see if this command will tell me whether bash is my default shell or if I'm using a different default shell. And ultimately it comes back with output of bash, which in this case is telling me that I am of course using bash as the default shell. Now when you look at the terminal, which again is running bash as the shell, you'll notice I have here before the @ symbol, Kyle, which in case is my name and also the username for my user on the system. The @ is referring to this is the user on this particular machine name, which is my machine's name is Kyle-virtual-machine. After the colon, you'll notice you have a tilde followed by a $. The $sign is the prompt for the shell. Now this tilde or squiggly line is actually referring to what directory I'm in. I'm going to discuss directories in the next video in more detail, but ultimately what this tilde means is that I'm in my user's home directory. Now, if I issue the command which in bash, it'll ultimately tell me where bash is located, which is the /user/bin/bash directory. So ultimately, in this case, I'm using Ubuntu 20.04. I'm using a desktop version. Keep in mind there are server versions out there that are as well. Server versions are strictly command line, whereas you actually can install GUIs on them, but in most cases people don't. Or you can utilize a desktop version which has a GUI. In the case this GUI is going to look something similar to this in the background, but I'm going to ultimately access the terminal by utilizing a terminal emulator or terminal program on the machine. So with that said, I'm going to go back to the PowerPoint now, and next we're going to discuss some ways of utilizing the shell that really make it easier for us to navigate. All right, so there are ways to make the shell easier to use. First of all, we have a lot of different built-in shortcuts. For example, we have the tab key. The tab key, when typing in a command that's not ambiguous, in other words, you type out enough letters of the command where the system knows that there is no other command you could be referring to. You hit the tab key once, it'll auto-complete the command. Now, if you type a command in that starts with a particular set of letters, like for example, TE, and you hit the tab key twice, it'll actually give you a list of all the commands that are available to you that start with those particular letters. We also have the command history. Shells remember what you have typed, whether you're using a Linux shell like bash, or if you're using the command prompt in Windows or the Cisco iOS on a Cisco-based device. Ultimately, you can retrieve previous commands you've entered by first utilizing either the up and down arrow keys. In some cases, there are other ways you can recall them as well. For example, on a Linux system using bash, you can use Control plus the R key to do a reverse search. Basically, you type in a command and you search whether or not it's within the history itself, or you can utilize the history command. The history command basically utilizes a file that keeps track of all the commands that user types in their home directory, and you can actually recall those commands by utilizing the exclamation point. And I'll show this concept after the next couple of slides. So first, again, we have the command completion. You can begin typing command or file path. If you type it properly, the tab key will auto-complete it. In other words, meaning it has to be a non-ambiguous text that you've entered. In other words, the shell knows that there is no other command you could be referring to. If the shell recognizes multiple options, typically, this can also be done if you hit the tab key twice, it's going to give you a list of all of the commands that are available. In this case, for example, I issued the command if, but I don't actually finish it. I just simply hit the tab key twice, and it gives me a list of all the commands that start with if, which if is one of them, but there are others available as well. Now, if I type in ifd I plus the tab key once, it's going to yield the command if down. Now you notice the I is not part of the command. Ultimately, it's going to look for the command that most closely represents ifd, which would be if down. And again, as mentioned, we can recall commands that we previously typed by referencing the history file. Every user has a history file in their user's home directory. For example, my history file on my system would be under the /home/Kyle directory. It's going to be a hidden file because, as I noted previously, any hidden files are going to start with a period. Actually, I did not mention that yet, but I will mention that at the end of the video. We also can recall history using the up and down arrows, as mentioned before. We can do a reverse search by typing Control plus R. Notice if we type if, we will ultimately see commands that we previously typed that started with if. In this case, if down would be one. And we can ultimately recall any other command that's been previously typed by utilizing the exclamation point character. So the .bash underscore history file keeps track of commands I type in the shell, as mentioned previously, and the history file can be viewed with the history command. And one thing you'll notice that's unique about the output, it has numbered lines of commands. And what that means, what you can do is you can utilize the exclamation point to, and then that number to call that particular command that's listed in the history file. So for example, and what's faster? I'm hitting the up arrow 1,704 times, which again is just a bizarre number we came up with, to get back to the first line in the history file, or simply just typing exclamation point 1. Well, ultimately we know that typing exclamation point 1 would be faster. Or for example, we could do exclamation point 1,701, and it will recall that command that's labeled in the history file with a line of 1,701. So again, the history file allows us to recall commands quickly. We can utilize the up and down arrows, or we can use the exclamation point and then the number that's associated with the command. Again, that number referring back to the line of the history file. And then finally, we have the list command. The list command, which is written as ls, lists the contents of a directory when issued without any command options. So again, it's one of those commands, a built-in command of most shells, including bash. And ultimately, what it does is simply lists by itself, it just says list contents of a directory, which includes files and other directories, but it does not show any hidden files. All systems, regardless if they're using Windows or Linux or Mac OS, have hidden files. The way you would view hidden files would be utilizing a command option with ls, which is ls-a. And again, ls-a will list the contents of a directory, including all hidden files and directories. Now, before I go to the Linux terminal, I do want to show you my sources slide. Again, I utilize online resources as well as a textbook. The textbook is the CompTIA Linux Plus LPI-1 Pearson Certification Guide, written by Brunson and Wahlberg. Again, a good textbook to refer to for the previous Linux CompTIA and LPIC exams. There are some newer updated books out there as well, but ultimately none of this stuff has really changed amongst different Linux distributions. So again, there's a list of my sources. Now what I'm going to do is I'm going to navigate back to Linux terminal, and I'm going to discuss what we just mentioned in terms of all of the different built-in options that make utilizing the command line easier. All right, so now I'm going back to the Ubuntu virtual machine. And I'm going to first use a command called clear, which is going to clear anything that's currently shown in the terminal. All right. Now, as mentioned before, I can start typing a command. For example, I could type TES. I could hit the tab key, and it will auto-complete a command. In this case, the command is test. Of course, as I said before, in order to auto-complete, the command has to be ambiguous. If I just type TE and I hit the tab key once, stop to show that again. I hit TE and hit the tab key once. Notice nothing appears because there are plenty of different, in other words, TE is not ambiguous by itself. There are a lot of different commands that can start with TE. Now, if I want a list of those commands, clear again, I can do TE and I can hit the tab key twice. And once I hit the tab key twice, I can see all of the commands that start with the letters of TE. And of course, as I mentioned, if I type like S, for example, after seeing that list, I can auto-complete the command, which of course is going to auto-complete the command test. Also, we mentioned the use of the history file. The history file, again, allows us to recall commands we previously typed in the terminal. For example, I can use the up key. The up key will ultimately show me commands I previously typed where I actually hit the enter key afterwards. Again, it will not type anything that I typed and erased with a backspace. It's only going to show commands that were actually run, which in other words means I typed the command and then I hit the enter or return key. And notice it includes clear, which bash, which again shows us where bash is located, and also the command echo space $0, which calls a special variable, which effectively tells us what default shell we're using, which of course is bash. I'm going to clear the terminal again. Now, if I want to see what's actually within the history file, I can run the command history. And within the history file, you can see 8 entries. Again, they're all numbered lines showing the first command I entered on the system. It was actually clear because I cleared the terminal history from before, and then I ran the clear command. I have the echo $0, and then of course the last command is history, which is one I simply just entered. Now, again, I mentioned I can use the up and down keys, but again, if I use the up key, it's going to go to the previous command. I have to scroll all the way up to get back to the first command. So if I wanted to do clear, which of course I could just type, but ultimately I'm trying to show you an example of using the up and down arrows and ultimately the history file and the history command. What I could do is I could scroll all the way up to clear, which I've ran it more than once, but in this case, I want to show you the first command entered on the terminal. Or what I could do is I can use an exclamation point, and then I can use the number associated with it. So if I do quote exclamation point and 1, well, it's going to run the clear command, which will clear the terminal. And if I recall the history command again, you'll notice that the next command, if you noticed previously before, I only had 8 entries. After I ran the clear command, it was entered again as a 9th entry. And after running the history command, it is now recorded as a 10th entry. So basically, anytime I type a command, even if it's a command I've typed before, it's updated as a new entry in the history file. Now you may be wondering, well, how do I delete the contents of the history file? This would be through the use of the command option. In this case, the command option is C. The C option will clear the history file. Now, again, what is the name of the history file and where is it located? Well, as I mentioned before, we can use the ls command, which is shorthand for list. And what it does is it lists the contents of a user's directory or a directory in general. In this case, it's showing the contents of my user's home directory, which ultimately is pointing to other directories on the system. Pretty much anytime you see anything blue on the terminal, in some cases it can be red, but in most cases it's going to be blue. Anything in blue is going to be referring to a directory. Anything that is a white text is going to be referring to a file. Currently have no files on the system, just directories. However, this is not showing me every directory or every file. As mentioned before, all different types of operating systems have hidden files and folders that most users aren't going to see, nor do they really need to see. But if you are a super user on the system or someone that interacts with the system every day, it might actually be worthwhile for you to know where the history, what the hidden files are, and ultimately where they're located, because you may effectively have to make different configuration changes to those files. or at the very least, you ultimately just need to know where that file is ultimately located. I can issue the ls-a command, which is again the ls command with the -a option. -a simply is referring to all, which means it's listing all contents of the directory, including anything that's hidden. And you'll notice I now list hidden files that start with periods, and or in this case, these are directories here. But I also show hidden files as well. It shows me bash history, bash logout, bash rc, and profile files. The bash rc, bash underscore logout, and profile are all files that are used when you're actually logging through, basically through the full use of the login process of utilizing an interactive login shell, which means you log into the shell, it opens up these hidden files, and effectively the process ends by you logging out. And ultimately, when you log out of the terminal by typing the logout command or exit commands, it'll ultimately run this script or file, and effectively you'll log out. But you'll notice I have the bash underscore history. This is the history file. Again, contents of the history command are going to be stored in this file, which again is in my user's home directory. All right, so with that, that concludes this video. Thanks for taking the time to watch this video. Again, if you have any questions, feel free to contact me. I will leave my email information in the comments or in the details of the YouTube video. Of course, leave a comment if you feel it's necessary to do so. Again, thank you for taking the time to listen, and have a nice day.